Okay, today an example of heat conduction through a thin layer. Well, imagine that we have a small cup, a small beaker like this, and we want to calculate how much energy is lost if we have hot coffee in it through this wall to the outside. Well, let's make first a drawing of the beaker. So, this is a simple beaker. And if we project the outside, then you could see that in fact we have two concentric layers. So we have an inner diameter and an outer diameter. And in this case, we want to calculate how much energy is lost to the surroundings. If this is a hot liquid with a cold surroundings, let's say 80 degrees C here and 20 degrees C here. Well, to calculate this, we apply Fourier's law, and we say Fourier says that the heat loss is equal to the conductivity through the wall, so the lambda of this wall, multiplied by the surface area. Well, it depends, of course, which surface area we take here, but let's first assume that we take a certain place, R, then we have a most general observation, multiplied by the height, and the height is, of course, the height filled with liquid, multiplied by the temperature gradient, in this case in cylindrical coordinates, because we have a cylinder here. Well, first we have to solve this, so phi q divided by lambda 2 pi and h 1 over r dr is equal to minus dt. We now have to integrate this both sides from t inside to t outside, respectively, and r inside and r outside. If you integrate this, then you get phi q divided by lambda 2p and height by the logarithm of r out divided by r in is equal to, well, there's a minus here, it should be T out minus T in, but there's a minus here, so I write down T out, T in minus T out. Well, if the temperatures are known and the radius, because we have a beaker, so in fact we know exactly the dimensions of this beaker, we can only thing we only have to know is the conductivity through the wall. Well, if the beaker is of stone, it would be 1 watt per meter per Kelvin, and if it's another material, it should be other values, but in this case we take 1 for simplicity, and now we can calculate the heat loss to the surroundings by substituting all these values, and we get a value of about 471 watts. Well, you see, it's quite a large amount of heat losing to the surroundings, but we have assumed here a steady state. A nice example would now be, how long does it take before this beaker becomes 20? But that's another exercise.